Hi, my name is Ms. De Leon, and today we're going to be talking about combining like terms. Our objective today. After today, I will be able to identify what coefficient, variable, constant, and terms are, as well as use this knowledge to simplify expressions by combining like terms. And our language objective. After today, I will be able to explain what the different parts of an expression are, as well as my process in combining like terms. So first of all, let's talk about a few vocabulary words. We're going to be working with expressions the rest of this week, and although you have already seen expressions, we are going to talk about these parts of an expression. So an expression contains variables used with one or more mathematical operations. An example is 5x minus 3, which I have here to the right of my screen, 5x minus 3. It contains variables. And variables are usually letters used to represent unspecified numbers or unknown quantities. In our example, our variable happens to be x. The reason it's called the variable is because it can represent anything. It could represent money, it could represent temperature. If you think about money, the amount of money you have now and the amount of money you will have in a week varies. It can change. So because of it, we call it a variable. Coefficient is the number in front of the variable. In our example, the coefficient happens to be 5. A constant is the number by itself with no variable. It's called a constant because it doesn't change. In our example, the constant is 3. And it's always going to be a 3. That 3 is not going to change to a 7 or an 8. It's going to stay at 3. It's going to be constant. Terms. These are numbers or variables separated by an addition or subtraction sign. In our example, we have two terms, 5x and 3, and they're being separated by the subtraction sign. We're going to talk about like terms. And like terms are terms that have the same variables and powers. So right now what I want you to do is I want you to pause me and I want you to copy down everything on this slide. Okay, so let's talk about some examples of like terms. 2x and 3x are like terms because they both contain x's, and these x's are raised to the first power. Some non-examples are 2x and 3y. One has an x, the other one has a y, so they're not considered like. Another example is 4xy and 5xy. They both contain an x and a y, therefore they are alike. Some non-examples are 2xy and 5xz because one contains a y while the other one contains a z. And some more examples are 3x squared y, 7x squared y, because they both contain an x raised to the second power and a y raised to the first power. Some non-examples would be 3x squared y and 7xy, because one has an x raised to the second power while the other one only has an x which is raised to the first power. Okay, so now that we know what like terms are, let's do a few examples. First, I have 2x plus 3x plus y plus 4 plus x plus 9. It's a very long expression, and I want to simplify it. So, first of all, I'm going to look at my terms. I have 2x, so I'm looking at anything else that contains an x in this expression, and I have 3x and x. So those are my like terms. I'm going to go ahead and put a circle around them. Then I have a y, but I don't have anything else in my expression with the y, so the y stays by itself. I have a 4, which is a number, and I also have a 9. So those two are like terms. I'm going to go ahead and put a square around them. So now that I've identified my like terms, I'm going to combine them. So 2x plus 3x plus x gives me 6x. The y stays by itself. I cannot combine it with anything else. And a 4 plus 9 gives me 13. So once I combine my like terms, I end up with 6x plus y plus 13. My second example. 3x squared plus 3x plus y plus 4 plus 2x squared plus 3. So I'm looking at my first term, 3x squared, and I'm looking at anything else that is like it, something similar to it. Well, 3x contains an x, but it's not raised to the second power, so 3x squared and 3x are not like terms. I keep looking throughout and I find 2x squared. Since it contains an x and it's also raised to the second power, those are my like terms. I'm going to circle those. I don't have anything else with just an x, so the 3x stays by itself. I don't have anything else with the y stays by itself. I have a 4, which is a number, and I also have a 3. So those are like terms. I'm going to put squares around them. Now that I know what my like terms are, I'm going to go ahead and combine them. So 3x squared plus 2x squared gives me 5x squared. I cannot combine the 3x with anything, that stays the same. I cannot combine the y with anything, that stays the same. And 4 plus 3 gives me 7. So my answer is 5x squared plus 3x plus y plus 7. So now I want you to pause me and I want you to copy these examples down on your paper.